Hi dear students, welcome to Geeta's classes. In this class, we are going to find out some inverse Laplace transforms. This is a continuation of previous class. In the previous class, we have found out the Laplace transform of different functions by using various methods. So before going to this, all of you please be thorough with these formulas. All the proofs are available in the previous classes. You can go through that. So all the theorems are available. Now let us do inverse Laplace transform. So you have to be thorough with these formulas for inverse Laplace transforms. These are the inverse Laplace transform of some standard functions. Okay. Then using the first shifting theorem, all the theorems what we have studied for Laplace transform, using that also we can find out inverse Laplace transforms. So first let us find out L inverse of 2s squared minus 6s plus 5 divided by s cube minus 6x squared plus 11s minus 6. Here take the denominator and factorize them. You can factorize this as s minus 1 into s minus 2 into s minus 3. So using partial fractions you have to separate them. A by s minus 1 plus b by s minus 2 plus c by s minus 3 because they are linear factors. Okay. Then you can find out the values of A, B, C like this, or you can take LCM like this, A into S minus 2 into S minus 3 plus B into S minus 1 into S minus 3 plus C into S minus 1 into S minus 2 is equal to S squared plus 6s x squared minus 6s plus 5. Then you can expand this s squared and corresponding coefficients you have to equate them and find the values of ABC. Okay? Or you can directly find the values of ABC by using these things. So you have to substitute s is equal to 1, s is equal to 2 and s is equal to 3. We will get A is equal to B is equal to C is equal to. So after finding that, then it will be easy. 1 by 2 into using linearity property of inverse Laplace transforms. You can take 1 by 2 outside L inverse of s minus 1 minus 1 into L inverse of 1 by s minus 2 plus 5 by 2 into L inverse of 1 by s minus 3. So L inverse of s minus 1 is e power t, e power 2t and e power 3t. Next problem, find L inverse of 5s plus 3 by s minus 1 into a s squared plus 2s plus 5. Because you have a second degree equation, second degree polynomial, you have to write a by s minus 1. For linear factor, you have to write a by s minus 1. Here you have quadratic, that is second order, second degree. Therefore, bs plus c divided by s squared plus 2s plus 5. Then equating the corresponding coefficients, you take LCM and equate the corresponding coefficients. We will get ABC values. I have simplified this. You can find out how ABC values are to be found. So 5s plus 3 by s minus 1 into s squared plus 2s plus 5 is equal to 1 by s minus 1 minus of plus minus s plus 2 divided by. So separate them. So in the second part, L inverse of minus s plus 2 divided by s squared plus 2s plus 5 I am finding separately. So minus I can take it outside, s minus 2 by s squared plus 2s plus 5. So now you have to split. If whenever you have in the second degree equation in the second degree s in the denominator, then you have to split the constant according to the requirement. How will you find out? 2 into whatever value is there, that you have to take from the constants. Okay, so 2 into 1. So 1 you have to take from the constant, remaining will be 4. So s squared plus 2s plus 4 plus 1 plus 4. So s squared plus 2s plus 1 is s plus 1 the whole square plus 4. And in the numerator also whatever value is there, if you have s plus 1, you try to write this as a function of s plus 1. So here s plus 1, no? So s minus 2 is there, I want plus 1. So s plus 1 minus 1. Whatever is there, whatever is required, just add and subtract so that you can simplify. So s plus 1 minus 3. Okay, that's what we have written here, s plus 1 minus 3. Whatever, you need not worry about how to find out how to adjust and all. So whatever is there you write, and whatever is required. So plus 1 I want. So plus 1 and minus 1. So s plus 1 you can separate them. Minus 2 minus 1 is 3. Okay. So s plus 1 and separate them using linearity property, and s plus 1 means e power minus t into, you have to use s plus a or s minus a means you have to use first shifting theorem. So minus of e power minus t into L inverse of s by s squared plus 2 squared plus 3 by 2 into, here actually I want s squared 1 by s squared plus 2 squared if you take e power minus t outside. Because you have constant, so 2 should be there in the numerator. It is not available, so multiply and divide it by 2. Therefore, e power minus t cos 2t plus 3 by 2 into e power minus t sin 2t. Okay. And for the first function, this is only for the second part we have found out. Only for this part we have found out. Therefore, L inverse of the required function is equal to, write s minus 1 also. First term minus etc. Okay. Next is L inverse of 1 by s squared into s plus 3. Because you have s squared, you have to write a by s plus b by s squared plus c by s plus 3. And find the values of a, b, c. Substitute, and again it will be easy to find out the inverse Laplace transform. Then L inverse of s plus 3 by s squared minus 4s plus 13. I told you here, whenever you have quadratic form in the denominator, you have to split them. Okay, you try to write in terms of s plus a or s minus a. So 4 can be written as 2 into 2. So 2 into whatever is available, take that square from the constant. So 2 squared is 4. So 4 you take it from the constant 13. So you split it as 4 plus 9. Okay. So s squared minus 4 is plus 4. Plus 4 I am taking from 13 plus 9. So this can be written as s minus 2 the whole squared plus 9. And in the numerator you have s plus 3. I want s minus 2. I want to write the numerator also as a function of s minus 2. So s minus 2 and plus 2 you add. Whatever is there you write as it is. Then whatever is required in the denominator, s plus a or s minus a form. So here you have minus 2. So minus 2 plus 2. Okay. So s minus 2 and here 3 plus 2 5. Okay. S minus 2 plus 5 divided by s minus 2 the whole square plus 9. So 5 I am taking it outside here. Therefore it is L inverse of 1 by s minus 2 the whole square plus 9. So again s plus a or s minus a form, first shifting theorem. So e power 2t you have to take it outside and replace s minus 2 by s. So s divided by s squared plus here s divided by s squared plus 3 squared plus 5 into e power 2t into, now I want 3 squared here. So 3 squared means 3 should be there in the numerator. So I am multiplying and dividing it by 3. Therefore e power 2t into s by s squared plus 3 squared is cos 3t. For L inverse of 3 by s squared plus 3 squared is sin 3t. So next is again the similar question only. So here you have 10. 10 means 2 into 5, right? So 5 squared. This should be separated as, split it as 25 plus 4. That's what I have written here. S squared minus 10s plus 25 plus 4. S minus 5 the whole square. Again in the numerator you have s plus 3. So I want s minus 5. So minus 5 plus 5. So s minus 5 plus 8 and split them. Next is L inverse of, whenever you have log, tan inverse and cot inverse, then you have to remember that you have to go for differentiation. Okay. So let us take L inverse of, I want to find out L inverse of, another important point, please remember L of f of t is f bar of s. And L inverse of f bar of s is equal to f of t. Please remember this. L inverse of f bar of s. This you have to remember. Okay. So f of s, f bar of s, let it be let the given function be f bar of s. So f bar of s log of s squared plus 4 by s plus 9. And this can be written because log of a by b is log a minus log b. Using that we can split. And now differentiating with respect to s. This is very simple. It is not at all difficult. It is very, very simple. You have to understand. So whenever you have log, tan inverse, cot inverse, take the given function for which you have to find out inverse Laplace transform. You consider that function to be f bar of s. Then differentiate. Okay, differentiate with respect to s. So in the left hand side it is f bar dash of s, and right hand side you differentiate. So 1 by s squared plus 4 into 2s minus 1 by s plus 9 because log. So now taking Laplace transform, inverse Laplace transform on both sides. Taking inverse Laplace transform on both sides. L inverse of f bar dash of s is equal to L inverse of 2s by s squared plus 4 minus L inverse of 1 by s plus 9. That is L inverse of, I am writing the same thing here. L inverse of f bar dash of s is equal to 1 by L inverse of 2s by s squared plus 4. So 2 into cos 2t minus L inverse of 1 by s plus 9 is e power minus t, minus 9t. Okay. So what is L inverse of f bar dash of s? It is minus t into f of t. How will you get L of, we know that L of t into f of t is equal to minus d by ds of f bar of s. That is nothing but minus of f bar dash of s. Okay, d by ds of f bar of s, I am writing it as f bar dash of s. Therefore, inverse Laplace transform of f bar dash of s is equal to, this minus will come to the other side, therefore minus t into f of t. So L inverse of f bar dash of s can be written as minus t into f of t. That's why I am telling you, you have to be thorough with these functions. If you know these functions, then only you can do the inverse Laplace transform also. Laplace transforms, if you are thorough, you can find out inverse Laplace transform easily. So minus t into f of t is equal to right hand side function. I want f of t. What is f of t? L inverse of f bar of s. L inverse of f bar of s is f of t. Okay. Is equal to divided by this t will come to the right hand side and minus also will come to the right hand side. Similarly, log of 1 plus 16 s squared. To take LCM, s squared plus 16 by s squared. In the similar way, if you proceed. Always remember, whenever you have log, tan inverse, cot inverse, then log, tan inverse, cot inverse, you have to use f dash of s. Okay, f bar dash of s. Let the given function be f bar of s, then differentiation. And it is similar to the previous problem. And the cot inverse of s, same. Let the function be f bar of s is equal to cot inverse of s, then differentiate, then minus t into, take inverse Laplace transform on both sides, then simplify. It is also similar problem. Next is find L inverse of 1 by s into s plus 2 the whole cube. So whenever you have 1 by s into some function, 1 by s into some f bar dash of s, f bar of s, 1 by s into some f bar of s means you can use this method. That is without 1 by s, you take the remaining as f bar of s. Then find inverse Laplace transform of that f, that is f of t. So f of t is equal to 1 by s plus 2 the whole cube I have taken. Therefore L inverse of 1 by s plus 2 the whole cube. I can take, whenever you have s plus a or s minus a form, I can use first shifting theorem. So using that e power minus 2t into L inverse of 1 by s cube, that is L inverse e power minus 2t into L inverse of 1 by s cube is t squared by 2 factorial. Therefore L inverse of this is equal to 1 by 2 into f of t. Actually you know that L of integral 0 to t f of u du is equal to 1 by s into f bar of s. Okay. So this is the formula. So 1 by s into L inverse of f bar of s. L inverse of 1 by s into f bar of s is equal to integral 0 to t f of t dt. F of u du you can say, or f of t dt also you can say. Integral 0 to t f of t dt, or f of u du also you can say. So here for 1 by s plus 2 the whole cube we have found out an inverse Laplace transform. Therefore, if you multiply by 1 by s, then it is integral 0 to t. Whatever you have found out this inverse Laplace transform, that you have to integrate from 0 to t. Okay. So using Bernoulli's formula, extended formula for integration by parts, I am using the t squared. This is the first function, and integrate the e power minus 2t by minus 2. Then keep on differentiating the first bracket, keep on integrating the second bracket. So t squared will become 2t, 2, and here e power minus 2t by minus 2, and already you have minus 2. Again if you integrate, e power minus 2t by one more minus 2 will come, therefore it becomes 4. Here again one more 4 is there already, so one more minus 2 will come, it will become minus 8. Then cancel here 2 and 4, you will get 2, and 2 and 8 you will get 4. Okay, when you simplify you will get this function. Next is using convolution theorem, you have to find out L inverse of. Please remember, whenever the question they have mentioned that find the inverse Laplace transform using convolution theorem, you have to follow that method only. Otherwise, whichever you are comfortable with, you can use that method. Okay. So here use convolution theorem to find L inverse of s squared by s squared plus a squared into a squared plus b squared. So first function you split them. It is a product of two functions. So let f bar of s is equal to s by s squared plus a squared, and I am splitting this as s into s squared plus a squared into a squared plus b squared. Okay, so s by s squared plus a squared, s by s squared plus b squared. That is, one is f bar of s, another one is g bar of s. Then find the inverse Laplace transform separately. You will be getting cos at and cos bt. L inverse of this function f bar of s into g bar of s, according to convolution theorem. Here. So by convolution theorem, we get L inverse of s squared by s squared plus a squared into a squared plus b squared is equal to f of t star g of t. This star is convolution of two functions, convolution product. Okay, it is not just product, it is a convolution product. So convolution product, we have some definition. So L inverse of s squared by s squared plus a squared into a squared plus b squared is equal to cos at star, that is convolution product of cos at and cos bt. What is the definition? First function you write it as au, and second function in the place of t replace it by you have to write t minus u. Okay, so taking this again, I know the formula 2 cos a cos b is equal to cos of a minus b plus cos of a plus b. Therefore you multiply and divide it by 2 so that you can apply. A is equal to au, capital A is au, and capital B is bt minus bu. Okay, so a plus b and a minus b you find out. Now because it is cos, you have to integrate, no? So sine of. With respect to u, you are integrating. So combine all these terms. So au minus bu, that can be written as a minus b into u. Similarly, in this second term, au plus bu, so I can write it as a plus b into u. Okay, and integrate, then substitute the limits. Upper limits t separately, then minus lower limit 0. Okay, so these two terms are for upper limit t. Wherever you have u, replace it by t, and for the lower limit, wherever you have u, replace it by 0, and simplify, you will be getting this function. Okay, and I have uploaded a separate class for convolution theorem. There I have done 4 or 5 problems. Please go through that, and the same question I have done in that class also. If you want, you can go through that, or you try on your own. This is the answer, 1 by 2 into 1 minus e power t into sin t cos t. And you can apply the same method for finding this problem also. Take it as a practice problem. Find L inverse of s by. In the previous one, s squared by s squared plus a squared into s squared plus b squared we have found out. Now s by. So one is cos, another one is sin. Okay. So cos of 1 by 3 into cos t minus cos 2t. This is the answer. Please check. Hope this will be useful, and in the next part I am going to do the solution of differential equation by using Laplace transforms. Okay. So please give a like and share it with your friends so that it will be useful for them also. Thank you so much for listening.